In my last lecture, I talked about Newton's Principia, specifically the definitions, his first 8 definitions that he gives. In this lecture, I want to talk about the Scholium that immediately follows his definitions. And as I said before, in his Scholia, what he does is he kind of sits back and talks about broader, more philosophical topics than in the rest of his text. So I want to talk about the Scholium on absolute and relative motion. And the question that Newton is asking here is, how can we tell? So let me write the question down. The question that Newton is asking, so first of all, this is his Scholium on absolute and relative quantities. And this is right after his definitions. And the question that he is asking here is, how can we tell if something is truly in motion or if it is at rest? So after all, if you think about it, it seems like all of our measurements that we make of objects are obtained by comparing the speed of one thing to another thing. So for example, when you're traveling down the road in your car, you say, I'm moving at 60 miles per hour relative to the road. You typically don't say that, but that's implicitly what you're doing. But the question is there truly a reference frame, an absolute reference frame, that we can determine whether something is truly at rest or truly in motion? And this question is not really a new question at all. It's been considered by many previous thinkers, and most recently at the time of Newton, it had been considered by Nicholas Copernicus and Galileo. The question that they were asking is the Earth in motion around the sun and the sun sitting still, or is the sun in motion around the Earth with the Earth sitting still? The older thinkers like Ptolemy and Aristotle and many others throughout the medieval times argued that the Earth was stationary and the sun was truly moving. Copernicus and Galileo and Kepler and others around and just before the time of Newton argued that the sun is truly stationary and the Earth is the thing that is in motion. But the question is, really both sets of people, both sets of philosophers were arguing that something was truly at rest and something else was truly in motion. And so now Newton is entering this discussion. Newton claims that motion, and for that matter time and space, are conceived by common people. He says vulgar people, but that just means common. They're conceived by common people only in relation to sensible physical objects. And I'll come back to that in a moment, what we mean by that. But Newton, on the other hand, would like to distinguish between absolute and relative quantities. Specifically, he wants to distinguish between absolute and relative time, absolute and relative space, and absolute and relative motion. So let's talk about these in turn. So first of all, let's talk about Newton's view of time. Okay, so he distinguishes between what he calls absolute or true and mathematical time, which he says flows without regard to anything external. Flows without regard to anything external. So there's this thing called time that is going at the same rate. It's flowing for everyone at the same rate. This he distinguishes from relative or apparent or common or vulgar time, which is a measure of duration, he says, by means of the motion of some sensible thing. So by means of the motion of some sensible thing. So for example, in this case might be the rising and setting of the sun. Or it might be the swinging of a pendulum. So we use the rising and the setting of the sun, that is the motion of the sun, the apparent motion of the sun through the sky, as a way of marking off days or hours. And likewise, we use the swinging of a pendulum to measure the elapse of time. Of course, we could use the beat of our heart, for example. That's the motion of our heart valves opening and closing to measure time as well. So in all of these cases, we would be measuring, as Newton says, relative time, because all of these examples that I'm giving here are measuring the duration of something by referring to the motion of some sensible thing or object. And he distinguishes that from what he says is absolute time, which even if there was nothing moving, so if there was no sun rising and setting, if there was no pendulum swinging back and forth, in fact, if you got rid of all objects and all kind of motion, there would still be absolute time. Time would still be flowing without regard to anything external. So he's asserting that even if there was nothing in motion, there would still be time, and time would still be progressing. Just as a side note, Einstein, when we get to the early 1900s, is going to consider absolute time to be something that is unmeasurable and hence nonsense to even talk about. He is an advocate of saying that the only kind of time we should ever be considering is relative time. Newton, on the other hand, says we should, at least in philosophical discussions, distinguish between relative time, these kind of practical measurements of time, and absolute time. Okay, that is Newton's concept of time. What about his concept of space? So let's go on to Newton's concept of space. Once again, Newton distinguishes between absolute space, which he says, get rid of these, which he says is unchanging and immovable. Unchanging and immovable. And would exist even in the absence of any bodies that currently occupy it. Any bodies or material that occupy it. So the idea here is that, yes, our universe is full of planets and stars and so on, but even if you got rid of all the planets and stars and so on, one can still conceive of there being space. And that is what he refers to as absolute space. It's kind of a, I'll just leave it at that. This he distinguishes from relative space. Relative space is a measure of absolute space by means of the distance between sensible bodies. So it's a measure of absolute space by means of the position, you might say, or the positions of bodies. Okay, so if you want to know the space between the Earth and the Moon, that only makes sense because you're referring to the position of the Earth and the Moon, and the space is between them. Okay, so if you think about it, all of our measurements we typically do are measurements of relative space. So what's the distance between the two ends of a ruler? That only makes sense if the ruler has two ends and you're measuring the distance between them. And again, what Newton's trying to do here is saying, although in practice, I recognize that all of our practical measurements are of relative space because they refer to objects, even if you got rid of these objects, it would still be conceivable to talk about absolute space, something that exists apart from any object in it. And once again, the idea that this idea of absolute space, just like Einstein will later reject the idea of absolute time, Einstein will reject the idea of absolute space. He's going to claim that since absolute space cannot be measured, it's nonsensical to even talk about it. Okay, and one other thing maybe I should say is that relative space, for example, the space that is occupied by our atmosphere, so the Earth's atmosphere occupies some space, this relative space in Newton's conception is movable. So as when the Earth is flying through space and the atmosphere with it, that space around the Earth is moving with the Earth through space, through this absolute space. Okay? All right. Now, let's go on to the third thing. I guess I didn't mention this at the outset, but I'll mention it now. Place. And once again, Newton distinguishes between absolute place. And absolute place, he says, is the part of absolute space that a body takes up. The part of absolute space that a body takes up or occupies. So if you have, let's say, a boat or a coffin, its place is the part of absolute space that the body takes up, as opposed to the idea of relative place. Relative place is the part of relative space that a body takes up. Or occupies. Okay, so going back to the example of the atmosphere and the Earth, if you have an airplane, then that airplane is going to occupy a part of the relative space that is around the Earth. Okay. And finally, we've talked about absolute and relative time, absolute and relative space, absolute and relative place, and finally, let's talk about absolute and relative motion. Okay, so, and once again, Newton distinguishes between absolute motion, which he says is the translation or the motion of a body from one absolute place to another. Think of translation as like sliding along. The translation of a body from one absolute place to another, right? And this is distinguished in Newton's thinking from relative motion, which is the translation of a body from one relative place to another. Okay, so if a person is walking on the deck of a boat, for instance, then he is in motion relative to the boat. So he's going from one place on the surface of the boat to another place on the surface of the boat. So he would be in motion relative to the surface of the boat. This boat, however, might be in absolute motion, for example. It might be moving from one absolute place to another. That is, if there is this absolute space, then this boat could be moving, or it could be stationary compared to this absolute space. Why don't I stop there, and I'll start out my next lecture with giving an example for us to work through of absolute and relative motion.